Have you ever looked up at a plane soaring through the sky and wondered, how is that even possible? It's a question that has fascinated humans for centuries. Since the dawn of time, we've gazed at birds and dreamt of joining them in the clouds. Today, millions of people fly every day. Massive metal birds carry us across continents in a matter of hours. But how do they actually do it? What magic makes flight possible? The answer lies in understanding the fascinating science of flight. For a long time, humans could only dream of flight. We yearned to touch the sky, to soar like birds. Then came the pioneers, the inventors, the dreamers who refused to stay earthbound. They experimented, they failed, they learned, and finally they achieved the impossible sustained, controlled flight. The first successful airplane took to the skies in 1903. The Wright brothers, Orville and Wilbur, made history that day. Their invention changed the world forever. Today, planes are a common sight. They connect people and places like never before. But the wonder of flight remains as strong as ever. To understand how planes fly, we need to know about the four forces at work: lift, gravity, thrust, and drag. These forces are like characters in a play, each playing a crucial role. Let's start with gravity. We all know about gravity. It's the force that keeps us on the ground. It pulls everything towards the center of the earth, including planes. So, how do planes overcome gravity? This is where lift comes in. Lift is the force that pushes the plane upwards, counteracting gravity. How is lift generated? Think of a bird's wing or a plane's wing. They are not flat. They have a special curved shape called an airfoil. When air flows over this curved surface, something interesting happens. The air traveling over the top of the wing has to travel farther and faster than the air underneath. This difference in speed creates a difference in air pressure. The pressure below the wing becomes higher than above the wing. This higher pressure underneath pushes the wing upwards, creating lift. It's a bit like magic, but it's all down to physics. Now let's talk about the other two forces, thrust and drag. Thrust is the force that moves the plane forward. It's like the engine of a car, pushing it along the road. In a plane, thrust is generated by the engines. They could be jet engines, propellers, or even rockets. Finally, we have drag. Drag is the force that resists the plane's movement through the air. It's like an invisible force trying to slow the plane down. The smoother and more streamlined the plane's shape, the less drag it will experience. We've met the four forces: lift, gravity, thrust, and drag. Now, imagine them as players in a tug of war. For a plane to fly, these forces need to be in balance. Lift needs to be greater than gravity to get the plane off the ground and keep it up in the air. Thrust needs to be greater than drag to overcome air resistance and propel the plane forward. When a plane is cruising in the air, it looks effortless, doesn't it? That's because the four forces are perfectly balanced. Lift equals gravity, keeping the plane at a constant altitude. Thrust equals drag, maintaining a steady speed. This state of balance is what allows planes to fly smoothly and safely. But what about maneuvering? How does a plane turn, climb, or descend? This is where the pilot comes in, using the plane's control surfaces to adjust the forces of flight. Section 4. Steering through the air. Imagine you're holding a paper airplane. You can make it turn by gently bending the flaps at the back. A real airplane has similar flaps, called control surfaces, which the pilot uses to steer. These control surfaces allow the pilot to manipulate the four forces of flight, making the plane turn, climb, or descend. At the back of the wings are ailerons. These move up and down, one going up while the other goes down. This controls the plane's roll, making it bank left or right like a bird tilting its wings. The tail of the plane also has control surfaces. The elevators, located on the horizontal part of the tail, control the plane's pitch, whether the nose points up or down. Then there's the rudder, located on the vertical part of the tail. The rudder controls the plane's yaw, allowing it to swing its nose left or right like a boat turning. Finally, there are flaps located on the inner edge of the wings. These flaps extend downwards to increase lift, particularly during takeoff and landing when the plane needs that extra bit of help. Section 5. Marvels of Aviation. From the earliest gliders to supersonic jets, the world of aviation is full of incredible machines. Each type of aircraft is designed for a specific purpose, but they all rely on the same basic principles of flight. Giant airliners carry hundreds of passengers across oceans, their powerful engines generating immense thrust. Small propeller planes are used for short journeys, their whirling blades pulling them through the air. Helicopters with their rotating blades can hover in place and even fly backwards. And then, there are gliders, elegant and silent, relying solely on air currents and lift to stay aloft. Every time we see a plane take flight, it's a testament to human ingenuity. We've conquered the skies by understanding and harnessing the laws of physics. The next time you see a plane soaring overhead, take a moment to appreciate the science that makes it possible. It's a true marvel of engineering and a symbol of humanity's enduring spirit of innovation.